Standard definition video in the absolutely dominant DVD video disc format will be with us for some time to come. But the days of SD are clearly numbered. And with second and third generation HD cameras entering the mainstream, the switch to HD for professionals is going to be sooner rather than later. In the next few minutes, we're going to dissect the most affordable HD format available, HDV. Is it true HD? Yes. Is it a professional format? Yes again. Am I going to be able to back up those audacious assertions? Find out next on TechKNow. HD or high definition video is rather simple to define. Any video format with 700 or more lines of horizontal resolution is high def. For broadcast, that means only two things, 720p and 1080i. These two formats are strictly defined by the ATSC. 720p is broadcast with a frame size of 1280 by 720, and 1080i has a frame size of 1920 by 1080. Both of these formats are highly compressed for broadcast. For shooting, however, we have different needs. The problem is that the data rate of full-frame uncompressed 720p or 1080i video can easily top 1.7 gigabits per second, which far surpasses any reasonable in- or on-camera storage format available today. There are two possible solutions. One, hook the camera up to a very high-performance computer or VTR, or two, digitally compress the video stream so that it can be conveniently recorded to tape, disc, or solid-state media. All HD shooting formats use three methods to reduce the data rate of the video stream. 1. Reduce the color resolution. 2. Reduce the whole frame resolution. And 3. Digitally compress the image information and the data itself. The first clever way that the data rate can be reduced is by saving color at a lower resolution than the full black and white image. It's possible to get away with this without sacrificing too much perceptible quality because we are more sensitive to the luminosity, the brightness, contrast, and edges than we are to the chroma or color in a scene. There are a number of different chroma resolution reduction schemes that can be abstractly described in print as a ratio of three values, which we'll summarize here as a ratio of luminosity to chroma to chroma. 4 to 4 to 4, or 444, is uncompressed, and we have the same amount of full resolution luminance and chrominance information. 422 video has uncompressed full resolution luminance information, but only half resolution chrominance. This is the listed color sampling of the professional DVC Pro HD format, for example. 420 has a quarter of the chroma information and is what the HDV format uses. The initial number 4 in those ratios implies a full resolution frame of black and white video. Ironically, perhaps, most HD cameras do not actually shoot full resolution frames in many situations. In fact, HD Cam, DVC Pro HD, and HDV cameras all shoot the largest format 1080 video at a reduced vertical resolution. The trick has been around since the early 1950s and involves squeezing a wider frame or field of view onto a narrower frame of film, and then uncompressing the squashed image when it's projected on the screen in the theater. While this anamorphic process was originally developed to get a wider picture onto a relatively narrower piece of film, the modern anamorphic process is primarily a data-saving technique when used for modern HD shooting formats. Squashing process occurs at the pixel level. Here's how it works. Start with a full frame of 1920 by 1080 video with square pixels, which means a 1:1 pixel aspect ratio. Squash this frame down to 1440 by 1080. The pixels are now rectangular with a 1.33 to 1 pixel aspect ratio. When displayed with a square 1:1 pixel aspect ratio on a computer, for example, the 1440 by 1080 frame looks completely wrong. Change the pixel aspect ratio to 1.33, and the picture stretches out to create our glorious 16:9 widescreen frame. This saves about 33% of our data rate, which is the whole point of this exercise. The final way we can save space is with digital compression. All of the various HD shooting formats use multiple encoding algorithms to achieve digital compression of at least 4:1 on every frame, which is significant. For the professional HD Cam or DVC Pro HD formats, the intra-frame only encoding results in very high quality and very high data rate recordings. HDV, on the other hand, uses a much higher form of compression. Instead of saving each frame as a picture, the HDV format very cleverly encodes some frames with more detail than others and recreates the missing information on the fly during playback. The interframe compression is based on MPEG-2 encoding. So while every 15th or 12th frame is saved as a full frame using only intra-frame or spatial encoding, just like the other HD formats, the rest of the video frames are considerably more compressed and are recreated based on the data in surrounding frames. When compared with the unquestionably professional HD Cam and DVC Pro HD formats, we find that 1. HDV has reduced color resolution, which is not as important as 2. The resolution of the actual frame, where HDV equals or even exceeds HD Cam and DVC Pro HD. Still, in the end, 3. HDV is a much more highly digitally compressed format. There isn't a straight linear relationship between the data rate and the quality, however. And the quality of the camera itself is ultimately the most important factor. Simply put, a sub $1,000 consumer HDV camera will always be outshot by a $50,000 HD Cam camera. And that's not primarily because of any inadequacies of the HDV format.